So why do plates move? Plates move for three reasons. First, we talked about this already, the idea that the mantle is moving in convection cells because it's picking up energy from the core, which is making the actual mantle rise through convection cells towards the surface, transfer that energy into the crust, cool down, go back down to heat up the process, and starts again. And those were basically convection cells, which cause the mantle to move around. And because the mantle is moving like that, you're going to have some areas of divergence, and you see one right there, a divergent area, and you're going to have some convergent areas where the mantle hits each other. Every time you have a convergent area, you're going to have something like a trench. Every time you have a divergent area, you're going to have something like a ridge. And we talked about the fact that this happens because of the mantle convection moves the asthenosphere like a conveyor belt, which then moves the plates of the lithosphere hitting each other or away from each other or slide past each other. And that's why you have all those boundaries that we talked about. So, for example, you have the mid-ocean ridge because of the divergence zone, because basically the asthenosphere is moving, forcing the stretching of that continental or oceanic plate, causing it to crack, let magma seep through, and do a divergent boundary like we already talked before. And when you have a convergence zone, you're going to have basically the opposite happening. You're going to have melting of the crust and a trench and all of that, and a folding, causing mountains and things like that. And you see this pattern is happening here, and you see how the substratum or the asthenosphere is going to be moving underneath like a conveyor belt, which is then going to be causing the plates to move around, and they're dragged downwards by descending convection currents. And remember, this is all because the mantle is picking up energy from the core and taking it to the surface. Now, there's a couple more reasons, and they're basically tied to the same thing. But one thing is called a ridge push. Every time that mid-ocean ridge pushes the continent to the side, it's going to cause the plates to move to the side. So, if you look at the Earth as a sphere, you realize that a piece of the crust is further from, because remember, we've been seeing the Earth as a flat thing in all these drawings so far, but you have to remember the Earth is a sphere, so the Earth is actually, so if you have a ridge, say, in this location right here, as this ridge is pushing away, it's causing this piece of the crust to move away and sink downwards by gravity. And when you get the sinking lithosphere, it actually results in a plate motion on the other side, which is going to basically be moving away from the ridge, allowing the ridge to push the plate to the side as well. So it's almost like gravity is also happening, this whole process taking place, because as you create a crack and that crack pushes the plate away, it actually, gravity or the weight of the plate itself also helps the plate actually move away. We call that the ridge push. Okay, and that's why the plates away from the crack actually move a lot as well. Because remember, you're talking about very massive pieces of rock. So just the magma punching through would not be enough if it wasn't for the gravity actually helping out. And you also have the slab pull. It's the same thing. It has to do with gravity. And the slab pull happens because the plate that's sinking due to being more dense is going to be dragging everything behind it with it. So gravity of the sinking plate will actually cause the plate that's behind it to move as well. So imagine that, for example, somewhere down here, you have a sinking plate, and that as the plate sinks towards the center of the Earth, it will drag with it the whole plate that's ahead of it as well. So that's why, understand that gravity through ridge push and the slab pull will actually help remember we call the slab, that piece that's sinking underneath, will actually help the plates move around. And that's why the plates can move as much as a palm a year, depending on how much they're happening. So we saw this drawing before, and we talked about how it shows all the things, but let's just review the reasons why they're moving down here. You see the asthenosphere will obviously be moving in a convection zone this way, but as the magma cools, it's going to be moving downwards and sinking underneath, which is going to cause a subduction plate. So those magma currents are part of the reason while this is moving around. And you see there's going to be a hot spot over here. We're going to talk about that in another video. And then eventually this magma current will actually sink underneath again and form another convergence zone on that side. So magma currents are reason number one. And also the other reason, remember, is you're going to be having the ridge push off here, and this plate is basically going to be sinking and making it easier for the ridge to be pushing this way. And you also have the subducting plates, which are actually dragging the plates behind it by gravity as well. So between the slab pull, the ridge push, and the magma convection, that's why the plates move. Okay? And now you know everything you need to know about why plates move and how they move. And the last thing we have to do is talk about hot spots. So we'll see you in the next video.